Imagine inventing a medical treatment so profoundly powerful that it literally empties psychiatric wards overnight.
Right. Just totally clears them out.
Yeah. You give this pill to patients who have been, institutionalized for years, and suddenly they can just go home. It's a miracle.
But, and there's always a but with these things.
Exactly. A few months later, you realize your miracle pill causes permanent, uncontrollable physical tremors. Like, people's bodies are literally locking up.
It's horrifying.
So the pharmaceutical industry, they go back to the lab, and they eventually offer you a quote-unquote cure for those tremors. A new, vastly improved pill.
The shiny new model.
Right. Only later do you discover that this shiny new cure doesn't just stop the tremors.
Yeah.
It is secretly frying your entire metabolic system from the inside out.
I mean, it honestly sounds like a dystopian science fiction plot, but that is the exact real-world trajectory of modern psychiatric medicine.
Welcome to the deep dive. We're so glad you've pulled up a chair to the table today with us. We're looking at a massive stack of pharmacological history, clinical trial data, and neurochemical research today.
It is a dense stack, too.
It really is. And our mission today is to untangle what we can really only describe as a mechanistic mess. We are talking about the pharmacology of atypical antipsychotics, which are also known as second-generation antipsychotics, or SGAs.
And, this isn't just a story about chemistry. I mean, it is, but it's also a story about how a class of blockbuster psychiatric drugs was essentially defined by marketing just as much as by molecules.
Oh, absolutely.
How they supposedly revolutionized mental health. And the surprising, honestly, incredibly dangerous trade-offs they forced on millions of people.
So to understand what makes these modern drugs atypical, I feel like we first have to go back and look at the typical baseline they were actually trying to fix.
Yeah, we have to start at the beginning.
Which means dropping you, the listener, right into the 1950s. Because if you were looking at psychiatric medicine back then, the foundational idea that emerged, and still angers the field today, right, is the dopamine hypothesis of schizophrenia.
Yes, let's definitely set that baseline. So the theory basically posits that the positive symptoms of schizophrenia, and when we say positive, we don't mean good.
Right, like a positive test result, not a positive experience.
Exactly. We mean symptoms that are added to a person's baseline reality. So auditory hallucinations, delusions, paranoia. The theory is that these are linked to excess dopamine signaling.
Okay.
Specifically, there is way too much dopamine activity in a part of the brain called the mesolimbic pathway. So logically, the chemical solution was to build drugs that block dopamine receptors, specifically the D2 receptors.
And looking at the history here, the most famous early success story was this drug chlorpromazine, right? Introduced in 1952 by Henri Laborie and then popularized in Paris by Jean Delay and Pierre Dennecker.
Yeah, and it's hard to overstate how big of a deal this was.
Yeah. From everything in these historical notes, this drug was earth-shattering. I mean, before 1952, severe schizophrenia often meant lifelong institutionalization. And chlorpromazine suddenly made outpatient treatment a reality.
It was an absolute medical miracle of its era. But, and this is a big but, we quickly hit a biological brick wall.
Because the brain is complicated.
Right. The human brain doesn't just have one isolated dopamine pathway. Yeah. It has at least 4 major ones. And those early drugs, the first generation or typical antipsychotics like chlorpromazine or haloperidol, they were incredibly blunt instruments.
They didn't just target the mesolimbic pathway, right?
No, they carpet bombed all of them.
Wow. Yeah, I was looking at the notes on the brain's anatomy here, and it just blew my mind to realize how interconnected this all is. Because hitting all 4 pathways is exactly why the side effects of these early drugs were so brutal.
It's a cascade of unintended consequences.
Let me see if I have this straight for everyone listening. So first, you have the mesolimbic pathway. That is the target. You block the dopamine there, and the hallucinations fade.
Correct. That's the therapeutic effect you want.
But then the drug bleeds over into the second pathway, which is the nigrostriatal pathway. And if I understand the physiology correctly, that pathway controls physical movement.
It does.
So when you starve it of dopamine, you induce Parkinsonian side effects. Patients develop tremors, severe rigidity, acute muscle spasms, and if you use the drug long enough, it causes this thing called tardive dyskinesia.
Which is, honestly, arguably one of the most tragic, iatrogenic, meaning medically induced conditions we know of.
It sounds awful.
It really is.
Yeah.
Tardive dyskinesia involves involuntary, repetitive body movements. Often it's facial grimacing, lip smacking, or limb flailing. And the worst part is, even if you stop taking the drug, for many patients, those movements are completely permanent.
Permanent? That's horrifying. But it doesn't even stop there. because then the drug hits the third pathway, the tuberoinfundibular pathway.
Yeah, try saying that 3 times fast.
Right, but this one regulates a hormone called prolactin. When you block dopamine here, the brakes basically come off prolactin production and the levels absolutely spike. And that causes severe sexual dysfunction and something called galactorrhea.
Yeah, and galactorrhea is unexpected, inappropriate milk production.
Wait, really?
Yes. We are talking about patients, and this includes male patients, by the way, suddenly lactating because their hormones have been so dramatically derailed by the medication.
That is wild. And finally, there's the fourth pathway, the mesocortical pathway, which is heavily involved in cognition and mood. If you block dopamine there, you can actually worsen the negative symptoms of schizophrenia, right?
Exactly. You take away the hallucinations, but the patient becomes incredibly apathetic, emotionally flat, and they just lose all their motivation.
So just to give you listening a way to visualize this madness, it's basically like trying to fix a leaky faucet in your kitchen by shutting off the water main to the entire city.
Oh, that's a good way to look at it.
Right. Sure, the kitchen sink stops leaking. That's your mesolimbic pathway. The psychosis is gone. But now the city's fire hydrants don't work, which is your nigrostriatal pathway causing permanent tremors.
Right.
And the water tower on the edge of town is overflowing, which is your tuberoinfundibular pathway causing lactation. You solved one problem, but you systematically broke 3 other massive infrastructures in the process.
That is a brilliant way to conceptualize it.
Yeah.
You fix the leak, but paralyze the entire city.
But the crazy thing is, doctors just accepted this, right?
Yeah. What's fascinating from a historical perspective is that because these side effects, especially the extrapyramidal symptoms, the EPS, the tremors and stiffness, because they were so universal, the medical field just accepted them.
Like it was just the cost of doing business.
Exactly. For decades, psychiatrists assumed that severe EPS was simply the mandatory price of treating psychosis. In fact, if a patient wasn't experiencing tremors, the assumption was that the drug simply wasn't working.
Wow. Until a strange little compound from Switzerland showed up and completely broke the rules. Let's talk about the origin story of clozapine.
Clozapine changes everything. So it was synthesized back in 1958 by chemists at Wander AG, which is a Swiss pharmaceutical company. It was part of a series of tricyclic compounds, chemically related to early antidepressants. But in the lab, clozapine was incredibly weird.
Weird in what way? Like chemically?
Behaviorally in the testing phase, it completely failed the standard animal testing protocols at the time.
Oh, interesting.
Back then, if a pharmaceutical company was screening a new chemical to see if it would work as an antipsychotic, they gave it to rats. If the drug worked, it would induce a state called catalepsy in the animals.
The notes describe catalepsy as this, like, waxy immobility. Basically, if the researcher took the rat and physically posed its paws in a weird, unnatural position, the rat would just stay frozen like that, like a little action figure.
Exactly, yeah. Every single known antipsychotic caused that frozen cataleptic state in lab animals. It was an absolute gold standard test. But clozapine...
That didn't do it.
Nope. Clozapine didn't cause it at all. The rats just kept moving normally. So because it lacked this quote-unquote essential property, the scientific community largely dismissed it. They assumed it was a dud that wouldn't actually treat psychosis in humans.
But they did eventually test it in humans, and it wasn't a dud at all. It was wildly effective.
Wildly.
And yet, there was a massive tragedy that almost erased this drug from history before it ever really got off the ground.
Yeah, this is a really dark chapter. In 1975, disturbing reports started coming out of a cluster of hospitals in Finland. Patients taking clozapine were suddenly developing a granulocytosis.
Which is?
It's a sudden catastrophic collapse of your body's white blood cell production.
Yeah.
Without white blood cells, your immune system basically vanishes.
Oh, wow.
Yeah. Several patients in Finland contracted minor infections and died rapidly. So Sandoz, the company that had absorbed Wander AG by that point, they immediately withdrew clozapine from almost all markets globally. For over a decade, this drug was basically locked in a vault.
So how did it ever see the light of day again? Because, I mean, clozapine is very much still prescribed today.
Its resurrection is one of the most dramatic turning points in modern psychiatry, honestly. In 1988, a psychiatrist named John Kane managed to secure funding and permission to run a landmark, highly controlled study.
Who was he testing it on?
He wanted to test clozapine on a very specific, desperate population, genuinely treatment-resistant patients. These were individuals who had already failed at least 2 rigorous trials of the old standard antipsychotics and were still suffering from severe psychosis.
And the results from Kane's study, they're staggering. According to the source data here, the control group who were given the old drug chlorpromazine saw about a 4% success rate, which is pretty dismal.
Sure.
But the clozapine group,
Clozapine produced clinically meaningful dramatic improvement in roughly 30% of these highly unresponsive patients within just 6 weeks.
that is a huge jump.
It was a statistical landslide. I mean, it worked for people that absolutely nothing else could touch.
And crucially, it didn't cause those horrifying Parkinsonian tremors we talked about earlier.
Precisely. It was so undeniably effective that the FDA approved it for use in the U.S. in 1990. However, because of the 1975 deaths in Finland, the FDA attached an incredibly strict, mandatory blood monitoring program.
So they still had to watch out for the immune system collapse.
Right. Patients had to get their blood drawn weekly to check their white blood cell counts, or the pharmacy legally couldn't dispense the pills.
Which is a massive logistical hurdle for anyone, let alone someone struggling with severe schizophrenia.
Very true.
But conceptually, this single drug blew the entire scientific consensus wide open, didn't it? It proved that you didn't have to induce movement disorders to cure psychosis. You could actually separate the two. And this, if I'm tracking the history right, is where the word atypical really enters the lexicon.
It is. The field was suddenly desperate to classify this rule breaker. And this is where we get into that mechanistic mess we mentioned at the start of the deep dive.
Yeah, let's get into the mess.
The definition of the word atypical began to shift repeatedly, almost entirely backward, just to accommodate clozapine and the inevitable copycat drugs that followed it.
Wait, walk us through that. How do you define a scientific category backward?
Well, initially, in the 80s and early 90s, the definition was purely clinical. It was basically a negative definition.
Like defined by what it wasn't?
Exactly.
Yeah.
If a drug treated psychosis but didn't cause the stiffness and tremors of, say, haloperidol, they just called it atypical.
So it literally just meant not typical. It wasn't a chemical description at all.
Not at all.
Yeah.
But, pharmacologists hate a clinical observation without a mechanism. They need to know why it works. So the goalposts moved.
Of course they did.
In the late 1980s, a researcher named Herbert Meltzer championed a new idea called the serotonin-dopamine antagonism hypothesis, or SDA.
Okay.
He argued that what made clozapine unique was that it aggressively blocked serotonin receptors, specifically the 5-HT2A receptors, while only weakly blocking the D2 dopamine receptors.
Ah, I see.
And for about 20 years, that became the textbook definition of an atypical drug. High serotonin block, low dopamine block.
But looking at the timeline we have here, that theory completely falls apart too. Because later on, a drug called aripiprazole hits the market. And from my understanding of the notes, aripiprazole isn't an antagonist at all, right? It's a D2 partial agonist.
Which throws a massive wrench in the SDA theory, yes.
For those of us who aren't neurochemists, let me try to translate what a partial agonist is, because this is fascinating.
Go for it.
So the old drugs were like a pure on-off switch for dopamine. They just shut the power off completely. But a partial agonist like aripiprazole, it acts more like a dimmer switch, right?
Exactly.
If dopamine is dangerously high, it dims it down to reduce the psychosis. But if dopamine gets too low, it actually provides a little baseline stimulation, keeping the system from shutting down entirely.
That is a flawless analogy.
Yeah.
It modulates rather than blocks. Furthermore, there's another drug used widely in Europe called amisulpride, which has almost zero serotonin activity. Yet clinically, it behaves like an atypical. It doesn't cause the severe tremors. So the serotonin theory couldn't explain the whole class. The goalpost had to shift a third time.
It's just a moving target. So what's the reigning theory now then?
In the early 2000s, a researcher named Shati Kapoor developed the fast dissociation theory. The idea here is that these newer atypical drugs bind to the dopamine D2 receptors very loosely, and they pop off or unbind very quickly.
Okay, I need another analogy here to wrap my head around this.
Let's hear it.
So if the older drugs are like a bouncer who completely locks the front doors of a nightclub, so absolutely nobody gets in, ruining the whole party.
Right.
These new fast dissociation drugs are like a bouncer who just stands in the doorway. They slow the crowd down enough to keep the club from getting chaotic, that's reducing the psychosis, but they still let a few people slip past to keep the party alive. And that little bit of normal dopamine slipping past is enough to spare the movement pathways.
Yes, exactly. They hit the receptor fast enough to treat the hallucinations, but they get out of the way fast enough to allow normal physiological movement.
But hold on, stop. Are you saying they fundamentally altered textbook pharmacological classifications just to fit a marketing narrative?
Basically, yes.
I mean, they found one drug that didn't cause tremors and then spent 3 decades twisting the scientific theory just to justify putting a bunch of wildly different chemicals into the same bucket. That's like a car company realizing their new brakes don't work, so they just redefine what a stop sign means.
Yeah, are echoing the exact frustration of many modern pharmacologists. The typical versus atypical divide is largely considered obsolete in cutting-edge science today.
Really?
Yeah. The members of the atypical class actually differ from each other more than some of them differ from the older typicals. Really, we should just classify each drug by its unique receptor binding profile.
But the pharmaceutical industry loved the bucket.
Oh, they loved it.
You can see why. I mean, the success of clozapine kicked off a massive gold rush. Every company wanted to create a drug that had the magical benefits of clozapine, but without the deadly white blood cell risks.
And that gold rush gave us the core atypicals that dominate psychiatry today. Risperidone in 1993, olanzapine in 1996, quetiapine, ziprasidone, and aripiprazole.
The heavy hitters.
The marketing engine went into absolute overdrive. The pharmaceutical industry positioned these new, incredibly expensive drugs as categorically, universally superior to the old cheap generics.
Which leads to the massive misconception that I know we need to puncture today. Did these expensive new drugs actually treat the disease of schizophrenia better?
So the pervasive myth was that atypicals were inherently superior at fighting the psychosis itself.
Right.
To finally test this, the National Institute of Mental Health funded a massive, real-world, independent comparison study in 2005. It was called the CATIE trial. They took several of these shiny, expensive new atypicals and put them head-to-head against one older, much cheaper drug called pirfenazine.
And if you're a doctor reading the New England Journal of Medicine in 2005, the headline result from the CATIE trial was an absolute bombshell.
It completely stunned the field. First of all, the trial showed that about 74% of all patients across every single arm of the study discontinued their assigned medication before 18 months.
Wait, pause on that. 74%. Almost 3/4 of the patients dropped out of the treatment.
Yes. Mostly because the drugs either stopped working or the side effects were too unbearable.
Wow.
That alone was a sobering reality check on how, quote-unquote, miraculous these drugs were. But the real shocker was that the older, cheaper drug, pirfenazine, performed roughly just as well as the newer, far more expensive atypicals on the primary outcomes.
Unbelievable.
And a year later, an independent UK trial called Cut-La-Masse felt the exact same thing. No quality of life advantage for the expensive second-generation drugs over well-dosed first-generation ones.
But if large, independent, publicly funded trials prove they weren't vastly better at treating the actual psychosis, how did the industry convince the entire world that atypicals were categorically superior for over a decade?
This is where you have to look very, very closely at how the early clinical trials were designed.
Okay.
When pharmaceutical companies were running the initial trials to get these drugs approved, they obviously compared their new drug against an older drug, right?
Naturally.
But skeptics and researchers eventually pointed out that they often compared their shiny new drug against extremely high, completely unnecessary doses of old drugs like haloperidol.
Oh, wow. So they essentially stack the deck.
Big time.
If you're designing the trial, you push the old drug at such a high dose that it is practically guaranteed to cause terrible movement side effects. And next to that artificially created misery, your new drug looks like a flawless miracle.
That is the core criticism, yes.
Yeah.
Now, to be fair, the atypical's real proven advantage is a lower burden of movement disorders. They do cause less EPS.
Right, which is important.
It's absolutely vital for patients' quality of life. But their marketing strongly implied superior efficacy against psychosis itself, and the independent data just doesn't support that.
But here's where it gets really interesting and honestly terrifying for the listener to consider. Because if they aren't magic bullets for psychosis and they successfully minimize the severe movement disorders, what do they do differently? Because they aren't side effect free, are they?
Not even remotely. What the medical field slowly realized is that we essentially traded the visible neurological side effects for invisible metabolic ones.
Okay, let's get into this.
We're talking about metabolic syndrome occurring as a massive class effect.
Walk us through what that actually looks like for a patient. How does metabolic syndrome manifest here?
Let's take olanzapine and clozapine as the prime examples. When patients start these medications, they can experience massive rapid weight gain. We're talking 4 kilograms, almost 9 pounds or more within just the first few weeks of treatment.
Just a few weeks.
Yes. But it's not just an increase in appetite. These drugs fundamentally alter the body's chemistry. They cause new-onset dyslipidemia, which means your cholesterol and blood fats go totally out of whack.
And the research highlights that this isn't just a byproduct of the weight gain, right? The drugs are actually directly interfering with how the body processes sugar.
Exactly. They cause direct insulin resistance.
No.
The molecules themselves actually impair the function of pancreatic beta cells, which are the cells that secrete insulin, and they decrease the body's overall insulin sensitivity.
Oh my God.
You can have a patient whose weight hasn't even changed that much yet, but their blood sugar is spiking wildly. It progresses incredibly fast to type 2 diabetes.
That's terrifying.
The pattern became so undeniable that in 2003, the FDA was forced to issue a class-wide warning on all atypical antipsychotics regarding hyperglycemia and diabetes risk.
So to bring back an earlier analogy, basically the medical field traded a mechanical failure for an electrical one.
I like where you're going with this.
Right. The older drugs gave you tremors. That's a visible mechanical problem with your body's movement. You can see it happening. These newer drugs look smoother on the outside. The patient isn't shaking, but the medication is secretly frying the internal electrical wiring of your metabolism. And by the time the check engine light comes on, the patient has full-blown diabetes.
That is a chillingly accurate way to put it, and it really highlights why lumping them all into one atypical bucket is so misleading.
Because they're all different.
Right, they are a diverse spectrum. While olanzapine and clozapine are at the extreme high-risk metabolic end, drugs like aripiprazole and risperidone are comparatively weight neutral.
Oh, interesting.
And then you have risperidone, which is classed as atypical, but it spikes prolactin hormone levels almost exactly like the older typical drugs do. Treating them as interchangeable is medically dangerous.
And the real-world stakes of this metabolic trade-off are literally life and death. If you look at the public health data, roughly 24 million people worldwide live with schizophrenia, and on average, they die 15 to 20 years earlier than the general population.
It is a devastating mortality gap.
15 to 20 years is massive.
It is. And a major driver of that early death is cardiovascular disease, heart attacks, strokes, which are, of course, heavily fueled by the severe metabolic side effects of the very medications keeping their psychosis at bay.
It's a catch-22.
Totally. This is why modern psychiatric guidelines strictly mandate that if you start a patient on an atypical antipsychotic, you must continuously monitor their weight, their fasting blood glucose, and their lipid panels.
So the industry successfully convinced doctors that these new drugs were these incredibly safe miracle workers, which leads to a terrifying natural consequence, right? If doctors think a drug is perfectly safe and doesn't cause tremors, they start giving it to everyone, not just people with schizophrenia.
Yes, the danger of off-label prescribing. Because atypicals were marketed as so much quote-unquote gentler, they started being used for all sorts of conditions they were never rigorously tested or approved for.
And the darkest chapter of this off-label drift occurred in nursing homes.
It really did. Throughout the 1990s and early 2000s, atypical antipsychotics became a go-to tool to manage agitation, pacing, and aggression in elderly patients suffering from dementia.
Wow.
In many understaffed facilities, they were essentially being used as chemical restraints to keep patients quiet and manageable in their beds.
Just to make sure we are totally clear on the gravity of this for the listener, these powerful metabolic drugs were being handed out like candy in nursing homes to keep dementia patients calm, a use they were never FDA approved for.
Never.
And what did the long-term data eventually reveal about that practice?
It revealed that it was actively shortening their lives. In 2005, the FDA had to issue their most severe alert, a black box warning.
For dementia patients specifically.
Yes. When researchers pooled all the trial data together, they found that elderly dementia patients who were given atypical antipsychotics had a significantly increased risk of death compared to those given a placebo.
What were they dying from?
They were dying from cardiovascular events, heart failure, and sudden severe infections like pneumonia.
It's a sobering, horrific reminder that when a drug's marketing outpaces actual medical evidence, vulnerable people pay the price.
Absolutely. And just to close the loop on the nursing home crisis, the data eventually showed the old drugs did the exact same thing to the elderly. By 2008, the FDA had to extend that black box mortality warning to the older conventional antipsychotics too.
So none of them were safe.
The bottom line is that none of these drugs are safe to casually hand out to agitated elderly patients.
We've covered a tremendous amount of ground today. If you're listening, let's try to pull all the threads together here.
It's been a journey.
We started with the brutal realities of the 1950s, We met a breakthrough drug, clozapine, that broke all the rules in rat trials and human brains alike. We saw how the pharmaceutical industry built a somewhat flimsy, shifting marketing category called atypicals to capitalize on that breakthrough.
Right.
And ultimately, we realized that while these newer drugs successfully minimize the horrifying physical movement disorders of the past, we simply traded those visible symptoms for a massive, invisible metabolic toll that is shortening lives today.
It is a story of shifting risks rather than eliminating them. We replace one set of profound, visible challenges with a set of hidden, systemic ones.
But before we sign off, we want to leave you with one final provocative thought. We want to look back at the drug that started this entire cascade, clozapine.
Ah, yes. This brings us to what we call the clozapine paradox.
The paradox.
We've established that clozapine has incredibly high risks: the white blood cell collapse, myocarditis, and a risk of seizures at high doses. But despite all of that, clozapine remains the only drug FDA approved specifically for treatment-resistant schizophrenia.
The only one.
And, even more remarkably, according to the 2003 Intercept trial, it is the only antipsychotic ever proven to actively reduce suicidal behavior in patients with schizophrenia.
But because of that tragedy in Finland back in 1975 and the massive 1990s-era blood monitoring bureaucracy that was built around it, doctors today are incredibly hesitant to prescribe it.
Very hesitant.
It is dramatically underprescribed for the people who are suffering the most and who desperately need it.
Exactly. So here is the lingering question we want you to mull over after you finish listening. We live in a world where untreated severe schizophrenia is an incredibly dangerous, agonizing, and life-threatening condition.
It truly is.
Has the rigid bureaucratic safety net built around clozapine actually started causing more harm through widespread undertreatment and missed opportunities to prevent suicide than the rare side effects it was originally designed to prevent?
That is a heavy question. At the top of the show, we talk about how easy it is to assume medical diagnoses and treatments are like clean, binary X-rays. You know, it's either broken or not broken. A drug is either safe or dangerous.
But it's never that simple.
Never. I think it's safe to say that when it comes to the neurochemistry of the human brain, the X-ray machine itself is broken. We are always operating in the muddy, incredibly human waters of trade-offs, and absolutely nothing is perfectly typical. Thank you for joining us at the table for this deep dive. Keep questioning the categories, and I'll see you next time.